So we already have seen what is a sensor and what is a transducer. Let us recap the previous lecture that we have discussed about. So the first thing that we discussed is related to sensors and transducers. What is the difference between a sensor and a difference between a transducer? So we have seen that sensor is something that not only converts one form of energy to the other form of energy, but also try to convert that output into a readable format or a measurable format so that one can quantify the input. So if you have temperature and if you want to detect, then you have to use a sensor which first converts the temperature into a say electrical energy, which is either a voltage or current or some other form of electrical energy. Okay, and then after that it will also help to measure this input and will provide a readable format. So at the end we'll be able to see whether it's 20 degrees centigrade or it's 30 degrees centigrade, etc. But in case of transducer, it just converts one form of energy to the other form of energy. That's it. Okay, then we have seen classification of sensors. Well, we can classify sensors in variety of ways based on physics, based on devices, based on other parameters like substrates, materials, etc. Then we have seen what are the sensors in human body. So there are a variety of sensors again, and the idea behind that was to give you an idea that in nature also you'll find several types of sensors, and currently in research people are trying to make similar sensors artificially. For example, e-skin, e-nose, e-tongue, so on and so forth. Then we have seen the sensor industry very briefly, just to give you an idea that in future the industry is growing. Maybe by 2030 we'll be able to see an industry of $500 billion US. And we also have said that sensor industry again can be classified in various ways. For example, biosensor industry, flexible sensor industry, silicon sensor industry, and so on and so forth. So almost in all these sectors you'll find the industry is growing. Okay, so there is a need of enough knowledge about this sensor so that we can work in this field in order to make advancement. Okay, then we have seen evolution of technologies, how different technologies have evolved over the period of time, and all these technologies helped in developing or advancing the sensor technology. So we have seen different representative timeline, at what time they came into the market or has been demonstrated, and that is also an important piece of information just to understand how we reached till this point as far as the sensors are concerned. So here I have again given you some of the application related to sensors, especially in the IoT domain. So you'll find people use different types of sensors for defense application, for surveillance application, for robotics application. In case of robotics, the application of sensor is something which determines how the robot will work. For example, the automation side of a robot is something that is controlled by sensors. Then we also have seen different types of sensors that are available in a car. For example, nowadays most of the cars comes with several types of sensors, so that if your door is not locked, that the car itself will give you an indication that you should lock the door. If you have not put the seat belt on, then again you'll get some indication. So the car is smart enough to decide all these things, and most of these smartness come from multiple sensors. Then in gaming application also you'll find sensors are used. In baby care also sensors are used nowadays. In hospitality industry also, sensors are used in different hotels and etc. You'll find smart sensors are used for the benefit of the users. Then in healthcare industry, which is very important nowadays, a lot of biomedical sensors and biosensors are in the market. So what is the purpose of those sensors is to decentralize the healthcare system to some extent. I discussed in the introduction. So in healthcare sector also there are multiple sensors that are currently in the market. And in the IoT, of course, you'll see different types of sensors. In security and in information technology as well, you'll find different types of sensors. So these are different types of applications where sensors are used. Now the thing is, why is transduction required? Transduction meaning the transducer effect. So there is a term transduction in the biology as well. It is not that transduction, okay? Here when I say transduction, I mean that a transducer effect that we have already discussed previously, the change or conversion of energy, right? So most of the sensors that we see around us are electrical sensors or electronic sensors. So we need to convert the physical parameter into electrical energy so that we can take that output to a system and process it as per our wish to give a indication to the user, right? So what I mean by that is, for example, again we'll take the example of temperature sensor. In this course you will find that I'll take example of temperature sensors very often, because this is a kind of sensor which probably you all can relate to, right? So if you take an example of temperature sensor, then if you plan to make a electronic sensor for temperature, then you need to convert this temperature into electrical energy, say in terms of voltage and current. Then you can feed this voltage and current into an electronic circuit having amplifiers, filters, oscillators, ADCs, microcontroller, etc. so that at the end you get a value in a display or in other form, as I have discussed previously, say in the form of different LEDs, right? So this particular conversion of energy is very important, otherwise you can't feed this output into different electronic system. And why we actually need electrical energy as an output? Because we have different components present already in electronics which can handle this electrical energy, right? For other form of energy we don't have this type of facilities or components available. So it's very easy to deal with an electrical energy or electronic signal compared to any other form of energy. That's why in most of the sensors transducer effect is necessary. However, there are sensors where you won't find any transducer effect because they probably do not need a conversion of energy. Let me give you an example. For example, if you want to measure eddy current in certain system, or current for example, or for the sake of argument, if we take current as an input parameter, that in certain, say in certain device you want to sense current, then you don't need to convert current into other form of energy, because current itself can be fed into different electronic system in order to detect, right? So in such a situation transducer effect is not needed, but almost in all the sensors you will find that transducer effect is needed, right? Then the question comes, why sensors? So why do we need sensors? So one of the primary objective of making a sensor is to detect certain physical parameter, not only detect but also quantify certain physical parameters, or maybe chemical parameters or something else, right? So nowadays it's a age of smart devices. You'll find almost all the devices are smart, be it a television, be it a refrigerator, be it a air conditioning device, or for example your mobile phone. Nowadays all the phones are smartphones. So that smartness actually comes from sensors. So each of these devices have more than one sensors in order to detect different other physical or chemical parameters. If you take example of your mobile phone, there is an accelerometer, there is a gyroscope, there is a camera, there is a touch sensor, so on and so forth. So all these sensors actually help us to measure different other physical or chemical changes around it, and that is how the smartphone will be able to, or smartphone is able to tell you information about its surroundings or information about different other activities, right? So that is why we need sensor. Another need is for some critical applications. For example, we can take an example of healthcare. So nowadays, if you see the healthcare system, they are centralized at various locations. So if someone needs to get himself checked, health checkup, you need to go to an hospital or an pathology to do this testing. But these sensors will help us to decentralize the entire thing. In fact, sensors provides the scope of self-health monitoring, right? Personal health care. So nowadays we can make sensors, or we have sensors that can detect various health parameters, and for that purpose we need various type of sensors, because a single sensor may not be able to detect all the health parameters. So we need various type of sensors to detect that. Then in automation also we need sensors. For example, if you are making a robot, and if you want that robot to pick, say, this pen from some place, then the robot has to first come and detect that location. For that purpose you may need a sensor which will help this mechanical arm to decide where this pen is, and then it will hold it. Now when you hold it, you'll understand that first what you have to decide is whether you have touched that object or not. So for that purpose also you need a sensor. Then to grab it, you have to make sure that enough force has been applied. So you need a force sensor or pressure sensor to decide that. So all these sensing mechanisms together help that robotic hand to decide what to take or what to grab, how to grab, and when to grab. So all these feedback mechanism. So there is a feedback mechanism. The moment you touch that pen, there should be a feedback to its system. In this case, for my hand, the control is in my brain, right? The moment I touch, some signal goes to my brain, and my brain decides whether to grab it even stronger or firmly, or the way I have grabbed is sufficient enough to, take it. So something of that sort is happening in the robot also. So that information, that how much pressure has been applied, whether it has touched the object or not, when to take that object or uplift the object from its location, all this information goes via sensor to the system or control, right, which then controls the entire robotic hand. So for automation also you'll find there are multiple sensors required, right? And automation is a kind of technology which is needed in industrial processing and stuff. Nowadays, even for household activities, people are trying to make different intelligent robots. So in that also automation is required, right? So for those purposes we need sensors, and that is why we have seen that in the industry the demand is quite high, that the entire market is growing at a rate of say 10% around. Okay, now these are the types of measurements that we generally do. There will be a mechanical measurement, thermal, electrical, magnetic, optical, chemical, that are associated with sensors. So as far as the mechanical parameters are concerned, we can actually sense, say, velocity, angular acceleration, mass flow, force, torque, pressure, different types of parameters using a mechanical sensor. So in this case, all these can be measured by converting a mechanical energy into an electrical energy if your sensor is an electronic sensor. So as I've said, it's not mandatory that all the time you convert any form of energy to electrical energy, but it is mandatory to convert any form of energy to electrical energy if your sensor is electronic in nature. Okay, so in case of say temperature, specific heat flow, we need to convert thermal energy to an electrical energy for electronic sensors. Then there are electrical energy like voltage, current, charge, resistance, that also sometimes we need to measure, but in this case you'll find that conversion probably is not needed if we are using a electronic sensor. Then for magnetic energy, there are different parameters that we can sense like magnetic moment, flux density, field intensity. For optical energy, there is intensity, phase, wavelength, so on and so forth. Then for chemical energy, there are composition, concentration, reaction, pH. These are the types of measurements that are required. So this is a brief, or I would say summarized details of different form of energies that probably a sensor engineer will work with. Then there are different types or different sensor classification. So sensor here, different sensor classification, and the examples are also given over here. So if you have physical sensors, so physical sensor mean pressure sensor, temperature sensor, strain sensor, piezoresistive sensor, or sensor for blood pressure monitoring or something of that sort. If you talk about chemical sensor, then there are gas sensor, clinical analysis, environment and process control, something of that sort. If you say a sensor is piezoelectric sensor, then it can be a pressure sensor, strain sensor. If it's a capacitive sensor, then it can be pressure, temperature, strain. Again, if it is an optical sensor, then it can be a photodiode, it can be a phototransistor, it can be a color sensor. If it's an acoustic sensor, then it can be ECG sensor, it can be ultrasonic sensors. So it's actually not ECG, it's echocardiogram, which also is known as echo. It can be an environmental sensor. If it is a magnetic sensor, it can be used as a Hall sensor, magnetotransistor, and so on and so forth. So we can classify the sensors and we can see different applications here. So one interesting thing here that you may observe, that the pressure sensors also comes in different types of classifications, right? So a pressure sensor can be termed as a physical sensor, a capacitive sensor also can be a pressure sensor, a piezoelectric sensor can also be a pressure sensor. So as I have said, that the classifications are interlinked with each other at times, right? So a polymer sensor can be a MOSFET based sensor as well. A polymer sensor can be a flexible sensor as well. So they are kind of interlinked. It depends on what are the properties that you see in a sensor. Based on that, you can classify them in different domains. So we also have different types of sensor terminologies associated with the sensor technologies, and all these terminologies are important. They are basically different parameters. So here I have listed around 19 to 20 parameters, and each of these parameters are important. So I'll just read out all these sensor parameters. For example, say accuracy is a parameter, precision is a parameter. So one may say that accuracy and precision both are same, but in sensors or sensor technologies, accuracy and precisions are very different. That we will discuss when we'll start discussing about different parameters associated with sensors. Then we have calibration, which is again important. We have sensitivity, we have threshold limit, we have offset, we have dynamic range, we have linearity, we have non-linearity. However, linearity and non-linearity both are kind of interlinked with each other. We have hysteresis, we have selectivity, we have repeatability. So selectivity is a parameter which is very important as far as the chemical and biosensors are concerned. Then we have reproducibility, we have resolution, we have stability, we have noise parameters, we have response time, we have recovery time. So response and recovery time both are interconnected to each other, but they are not same. In fact, they are not interlinked as well. Then we have another term called drift. So each of these parameters are important when you design a sensor. Based on the application, you have to decide these parameters. So one temperature sensor can have an accuracy of 98%, other temperature sensor may have an accuracy of 95%, right? So two different temperature sensors may have two different values for a same parameter. So it depends on the kind of application that you are targeting, the kind of design that you are making. Based on that, these parameters will vary. In fact, you'll find that there are variety of temperature sensors. One may think that why there are so many temperature sensors available in the market. If you have one temperature sensor, you can use that temperature sensor for all the applications, but that is practically not possible, because based on the application you have to change the sensor design and sensor specification that is mentioned over here. Some sensor may demand high accuracy, however in certain application, some application may demand high accuracy, however in certain application you'll find that a bit low accuracy is also sufficient. But in the second application where low accuracy is also sufficient, you can use this sensor, but maybe the cost of this sensor is very high. So there is no point in using a very high accuracy sensor or a sensor having high accuracy in an application where it is not needed. Then for that application, whatever you are making, the cost may rise. So there is a trade-off between all these parameters, and based on the application, as I've said, you have to decide what should be the parameter. Okay, but this particular thing will be much clearer, or you'll get a clear idea about all these parameters when we discuss about these parameters in the upcoming lectures. Okay,
Sensor terminologies are important because the terminologies that we have seen just now has different implication. For example, sensitivity, range, and different other terminologies that we have discussed are actually the indicator of how a sensor will behave once you start using that sensor. In many cases, you'll find that different sensor comes up with a data sheet which includes the details associated with those terminologies. You may find or you may not find all these terminologies that was listed before, but there are various important terminologies that usually are included in the data sheet. For example, say sensitivity is a parameter which is very important in most of the cases, and you may find that the sensitivity of that sensor is listed in the data sheet, and based on the sensitivity only you can decide the application and other details associated with the same. So in certain cases you may find some sensor has higher sensitivity, and in certain cases the sensitivity is lower. So the sensor having higher sensitivity probably is costly or costlier compared to the one that has lower sensitivity. So there is a trade off in terms of usage of a sensor, in terms of the cost associated with this and the specification of that particular sensor. So one has to decide the sensor accordingly. Just to give you an example, if you are planning to use a temperature sensor for body temperature measurement, then if the sensor has a range between say 20 degrees centigrade to 50 degrees centigrade, it should work. You do not need a sensor which has a range say from 5 degrees centigrade to 100 degrees centigrade, because the temperature or the body temperature lies in between 20 to 50 degrees centigrade in most of the human beings, in fact in all the human beings. So in that case, if you choose a sensor which has a range of 50 to 100 degrees centigrade, it will work. You can use that sensor, but the thing is, you may find that the sensor having this range, 5 degree to 100 degrees centigrade, has higher cost. So you have to pay more. So in that case, it's better you go ahead with a 20 degree to 50 degree centigrade temperature sensor, and it will work better in this case. So that is how one has to decide. This is just an example. There are other parameters also that you need to consider, like sensitivity, linearity, and stuffs like that, so that you can use that sensor for the system as well. So this is something one should remember when they are working with sensors. Although different sensors have different uh, parameters or different values of parameters, but one has to choose the most suitable one for their application. You will find that there are variety of temperature sensors available in the market. So each of these sensors has their own application. Some of the sensor can be applied for various applications, but in practice you may find that a specific sensor is chosen for that particular application. So what I mean by that, if you have temperature sensor like A, B, C, D, different options, and probably A is useful for application X, Y, and Z, you can use sensor A for all three. But still people are using, say, sensor C for application X, because sensor C is more apt for X. Maybe A has higher specification, as I've said over here in one example. Maybe A has higher specification that is needed for application X, and C has almost the similar specification that is needed. And in practice, you may find the cost of C is lower. Maybe this is 100 INR, and this is, say, 500 INR. So there is no point in using a sensor that costs more for the application where a low cost sensor is already available for this or can be used for this particular application. So that is how one should actually decide on different sensor, and that is why these terminologies are important. We will discuss these terminologies in details in the coming lectures, but in this particular lecture I thought at least to provide you certain idea regarding this, so that you are well aware about why we should study those terminologies in details.
So what are the three take-home messages from this lecture? First one is sensors are important in smart applications and automations. As I have said, in case of smart application, the smartness is directly related to the sensors. Even in case of automations, you need sensors because you need feedback, you need certain sort of idea about what that robot is doing. So for that purpose, you need sensors to be attached. Then in electronic sensors, the transducer effect converts all other type of energies into electrical energy. So if your sensor is electronic in nature, in that type of sensors you'll find that the transducer effect that I have said in sensor, that is converting all the physical parameters or the energy associated with that physical parameters into electrical energy, because we have components or system that can handle electrical or electronic energy precisely or appropriately. So we can make an electronic device or electronic application out of it. Okay. The third take-home message is there are multiple sensor terminologies and parameters that are important. So we have seen that there are almost 19 to 20 terminologies or parameters. In fact, the number of terminologies or parameters are even higher. Probably when we will discuss about those terminologies, we'll discuss about some more parameters or terminologies associated with the one that we have listed. So all these parameters are very important, and you have to decide those parameters based on the sensor application. Okay. So can a single sensor measure more than one type of energy? So what I mean by that is there a sensor which can measure two different types of energies or two different types of parameters? For example, say, is there a sensor that can measure temperature and pressure both? So you may think about this. So the application that we are targeting probably have more than one parameters associated with that. Is it possible that we use only single sensor to detect both of them? So you may think and then check if it is possible or not. Okay. So in the upcoming discussion, we will discuss about sensor terminologies. We also will discuss about materials and multidisciplinary aspect associated with sensor. Thank you.